Hello and welcome. Welcome back. Now we're going to go to the second part of the class and it's rules of arithmetic and algebra. So the first question is, use the basic rules of arithmetic to simplify the following problems. Work out as far as possible, put on a common denominator, and etc. These are basically the things that, well, I want you to show yourself that you know how to do. And if you don't, well, you know what to work on. So let's make a couple of them together. And let's start with exercise A. Yeah, that seems like a good one to start with. Maybe red is a bit too bold. Let's do it in white. And it's 1 over a plus 2b. Okay, there's not that much that we can do with this, but we can put it on a common denominator. Well, how do we do this? Well, you can look up, but basically it says, well, this kind of thing and this kind of thing, well, how can we make them have something in common? Well, if we do this entire thing times a in both the numerator and the denominator, what will we have there? We will have 2a over ab. Well, we can make this on the numerator ab as well by multiplying times b in the numerator and the denominator. So let's do that once. So we get b times 1 over b times a. And remember, we're allowed to do this because we're just basically doing times 1. So we're not changing anything. And we're going to do this times 2 times a over b times a. Okay, now you see they are on common denominator and we can just add them together. So that means b plus 2a over ba. And we can't simplify it much further than that. So basically the entire goal of this was just to show that you can put things on a common denominator. Okay, then let's go to exercise B. Still pretty easy. It's just, you know, when you're being too quick during maths, you make like these small kind of errors. What happens when you add these things together? Well, some people might say, oh, you get a to the power of 2n. Well, no, because you're just adding them together. You're not multiplying them. So all you get is basically twice the original thing. So you get 2 times a to the power of n. Okay, again, not that hard. So C, in this case, well, there you have the answer of before. Because if you multiply things with the same base, which in this case is a, you will just get a to the power of n plus n, which is a to the power of 2n. Okay, this really has a short recap because these questions are very, very easy. Let's look at some things that are a little bit more challenging. Let's maybe move on to question, let's do question number D. And this looks already a little bit more daunting. A to the power of n over, and here have to be careful I write big enough, 1 over the power a times a over a to the power of n, and all of that to the power of n again. Okay, so let's start by simplifying some things, and I'll take a different color for this. Well, a over a, well, this is a bit, well, this doesn't mean anything. It's just 1, right? It's just 1. So 1 to the power of n, 1 raised to the power of anything will just always remain 1. So we can again simplify this. Maybe I can rewrite it. Just question for sake of clarity. So all that we have there is 1 over a times 1, right? And all of that to the power of n. Okay, so what do we have here now? Well, again, we can bring in this exponential, and you get 1 to the power of m over a to the power of n. So we get a to the power of n over 1 over a to the power of n. Okay, and now here, I would say this is the trickiest part of this exercise. Well, what is this actually? Well, fractions, because this is a fraction in the denominator, you can always like bring this back up by this nifty little trick. You can say a to the power of n over a to the power of minus m. All we did was we wrote this inversion in with a negative exponential, because a to the power of negative m is just 1 over a to the power of m. Maybe a little example. So 2 to the power of negative 5, it is just 1 over 2 to the power of 5. Sorry. 2 to the power of 5. Okay, so now with this, well, we can bring this back up again by just, well, reversing it again. And so what do we get? We get a to the power of n, because we're dividing, it's minus, well, no, I said we were going to reverse it again, so let's not skip a step. So we reverse it again, and now it's just going to be times a to the power of m, because, well, all we did is we brought it back up. Or you might say, well, division, clearly all I need to do is, well, minus minus m, and we'll get the same answer. That's also totally fine. It's just working through step by step. A to the power of n times a to the power of m, because already are the same base. Well, that means you can bring it all together and say a to the power of n plus m. And that's how you simplify question D. Question E, F, and G, well, I'm gonna let you try that at home. So we're gonna skip immediately ahead to question H. Question H, this is something you're gonna need a lot during the semester. So maybe let's start a new slide for that. Well, everybody knows about this thing, right? A plus B to the power of 2. Please never ever write this is a squared plus b squared, because it's simply not true. This is not equal to each other. Why? Well, let me show you. So I hope you will never forget. A plus b to the power of 2, well, that means that we're just going to multiply a plus b again with a plus b. So you get a times a, because of the law of distributivity, you have to go step by step, a times a, so you get a squared. Then a times b, and because the sign in between is a plus, we can say a plus b, so we get ab. See, here you already see this is something that the one on top doesn't have. Okay, we move along, and here it's a plus, so we can write plus again. B times a, which is just the same as saying a times b. Plus b times b, which gives you b squared, which gives you a squared plus 2ab plus b squared. Of course, I go really in detail here because I hope that I think for many people already know this, but for those who had forgotten or, well, didn't know, I hope you'll never forget now. Okay, so many people know about this, that it is equal to a squared plus 2ab plus b squared. But they don't know that much about the next identity because, well, wouldn't it be interesting if there's a way we do get a squared plus b squared? Well, you can do this by multiplying the complement. And the complement is just the same thing as what we did before, but you're gonna put a negative sign in between. So you're gonna alternate the signs. A plus b times a negative b. Well, if we work it out now, we find a squared plus, well, let me respect the order of operations, so let's not move around. Let's do it the same way as I did before. So let me remove that. It really doesn't matter, but just to stay clear. So negative sign, so minus ab plus ab, and then minus b squared. So what do we find now? Well, not something that's a squared plus b squared, but something very close, and we find a squared minus b squared. Okay, and why is this interesting? Well, and why am I talking about this entire thing? Well, if you look closely at h, there is a part of a and b that you can recognize. I'm gonna let you figure it out for yourself, but the answer is going to be 3x squared minus 30. How I got there, that's for you to find out. And, well, now that I explained all of this, I hope question I is not really a challenge. So we move on to question number L. L. So again, b times a to the power of m, all of that to the power of negative m. ba to the power of n. Okay, so again, we started with doing things in the brackets. Okay, let's have a look at that. Not really a lot we can do. Okay, but then here we have an exponential, and that has priority above the division. And here we have an exponential of, well, b, simply, but we also have an exponential of a, which already has an exponential. And an exponential to an exponential, you're going to multiply them. Because actually what's written here is a to the power of m times a to the power of m times a to the power of m times a to the power of m, and all of that in the denominator because there is a negative sign. So 1 over everything I just said. So basically you're going to keep doing that, but a to the power of m times, right? So what do we get? Well, we get some kind of multiplication. So let's work it out. So b to the power of negative m. Okay, that's not really interesting. That really doesn't do anything. And then we get a to the power of m to the power of negative m. And all of that over just what we had before. Okay, so b, we can just copy it. But here, well, that means we need to multiply them. So what do we get? We get a to the power of negative m squared. And then here you get ba to the power of n. Okay, so maybe let's simplify that in one go. So I don't have to write underneath anymore. And we can just say that's b to the power of n, a to the power of n. Okay, so division, well, we're going to try and simplify these things. So cancel this denominator out as far as we can. And because there's a multiplication, we can start scratching things out. But scratching this, that means you also need to take n out of here. So what do you get? You get, well, b to the power of negative m minus n. Because why? You take this n out of here. You divide them away. If you don't remember why that is, well, you can just bring it back up and you can find b to the power of negative n. And you can add these things together and you'll find the same thing. And then the same again for a. So you find a m squared. And then we can cancel this out as well, but that means we need to take n out of this. So we have simplified it as far as possible because after this we can't really do anything anymore. Well, what we could do is simplify and say, well, we take out all of the negative sign. So we could do that, and then basically you would find it's b over 1 over b to the m nth and a to the m squared to the power of n. So that's it for question L. If you find this or this, really doesn't matter. Both are the same to me, but you just have to prove that you can simplify these things and work it out for yourself. Okay, and then the last one in this series, let's go to M. I'm going to start a new slide for that as well. And this is with a lot of square roots. And here we're going to learn some nifty tricks as well. I'm going to write it big enough so I don't become short on space. A to the power of 1 times m times the square root to the power of m a b to the power of n, and then all of that to the power of n m. Okay, this is quite intimidating, but again, just work out step by step and you will see it's fine. So okay, we start really at the smallest brackets and we find it's ab to the power of n. So we can simplify that and we can just say it's okay, that's a to the power of n, b to the power of n, all of that under a square root. And everything else remains the same. We don't touch it. Power of n to the power of n m. Okay. Now, well, we can keep writing it, but a to the power of 1 is just a, right? So why? Because it's just a times, well, nothing. It's just a times 1, so a. So here, oh, I forgot the m here. Well, some of you might already know, but some of you might not. Sorry, it's when I'm trying to write something really small, I get in trouble. Select my pen again. and then here is to the power of m. So if you have a square root, so 4 square root, well, everybody knows that's 2, but there's another way of writing a square root. It's actually 4 to the power of 1 over 2. These and these are exactly the same. As this, because it's the inverse of a power, well, you need to be able to cancel these things away. So what does it mean? So 4 squared to the power to the square root. What does that mean? Well, it'd be neat if this disappears, if we just had 4, because we want these to be inverse operations of each other. So what do we need to do? Well, we need to divide that 2 away. So you see that this is actually just 1 over 2 in the exponent. So we can apply that here to this m. So what do we find? We find a to the power of n over m and b to the power of n over m. All of that times m, all of that times a. Because if remember, to the power of 1, nothing changes. And then again, well, we find this thing over here. The square root of to this n powered square root. And we can do much the same as we did before. We can just say 1 over n. Okay, so let's simplify. And then I have all of that to the power of n m. Okay, now there are a couple of ways to simplify this. Either you start by working out these things and bring that down, or you first work this out and then you work that out. I'll do it like this. So basically, because an exponent to an exponent, it means you're multiplying these things. That means that you can cancel some things. It means that this n and this n are going to cancel each other out. Okay. Now we can rewrite it, and all we get here is, well, basically to the power of m. So we get a to the power of m, m to the power of m, a to the power of n times m over m. So a to the power of n, because, well, okay, I'll write it so we can cancel this out, times b to the power of n for much the same reason. We can't simplify it any further. This is as far as you can go. I think this is enough exercises of the kind, but if this doesn't make sense, well, actually for everybody, prove that you can do these things for yourself too. So do exercise 1. Exercise 2, I'm just going to skip over